Today, we're going to look at defining rational exponents. Rational exponents are just exponents that are fractions. To begin, let's look at an example using a geometric pattern. Let's explore 27 raised to the 1/3 power. Remember, a geometric pattern of powers starts at 1 and is multiplied by the same number each time. To create our pattern, we will start with 1 and multiply by 3 for each sequential term. To give added context, we will go back and label the sequence using R as we discussed in our conversation about geometric sequences. Remember that R represents the constant ratio between consecutive terms. It's also the number that we multiply by each time to get the next term in our sequence. We can use our sequence to give meaning to the idea of 27 raised to the 1/3 power. We need to identify the value that is 1/3 of the distance between 1 and 27. If we label the distances between 1 and 27, we can see that 3 is 1/3 of the way between 1 and 27. Therefore, 27 raised to the 1/3 power equals 3. Notice that 3 and r are in the same location, as are 27 and r cubed. We could find this same solution by taking the cubed root of 27, which equals 3. Let's look at another example of rational exponents using a geometric sequence. For this example, let's look at 256 to the 1/4 power. Our sequence begins with 1 and is multiplied by 4 each time. We will again label our sequence with our constant ratio r, as well as the fractional distances of numbers from 1 to 256. 4 is 1/4 of the way between 1 and 256. Therefore, 256 to the 1/4 equals 4. We could find the same result by taking the 4th root of 256. Do you see any patterns? The two examples we just looked at are called unit fraction exponents. This just means that there's a 1 in the numerator. Using the pattern from our first two examples, we can see that x raised to the 1n power is the same as the nth root of x. For example, 9 to the 1/2 is the same as saying the square root of 9, or 3. Or 625 raised to the 1/4 is the same as saying the 4th root of 625, or 5. Still not convinced? Let's look at the pattern. Notice that 5 is 1/4 the distance between 1 and 625. Does this mean I have to use a pattern every time? No. That's why we established the rule up above. It's a shortcut. Not all expressions will work out to be perfect integers. Let's take out our calculators and look at one that doesn't. Let's look at 86 raised to the 1/3 power. That's the same as saying the cubed root of 86, or 4.414, so on and so forth. To write your answer as an exact amount, you should leave it as the cubed root of 86. If you are asked to approximate, you could round the cubed root to 4.4. Remember, this is just an approximation.